Hello everyone, myself Dr. Santame Kundu. I welcome you all to this lecture of soft computing techniques. This is the third lecture of module 8. So we have discussed about the NSGA and NSGA-II algorithm in the last class. So today we will try to understand this NSGA-II algorithm by some numerical examples. So first concept is that we want to know the non-dominating sorting. So what is the meaning of non-dominating sorting? So let's try to understand this concept. Suppose there are suppose there are four persons in a family. So the four persons, namely A, B, C, D. There are four persons in a family. So we want to estimate the dominance of their contributions. Okay. So we have two parameters. Suppose salary and savings. So the persons having maximum salary or maximum savings, we will assume that he is more dominating. So his contribution is more dominating. So the person A, the salary is in terms of rupees, so 200k, saving is 82k, B is 195k, and saving is 85k. C, the salary is 150k and savings is 65k. D is 140k and savings is 50k. So the persons having maximum salary or savings, his contribution is dominating. We assume that concept. Okay. So now try to understand. Take these two A, B, C, D. So in a queue or in a list you write A, B, C, D. So make another list A. Then you write here B, C, D. Now comparing. Now you need to compare the A with B, the dominance factor. So see that though salary of A is greater but saving is less, so you can say that A is not dominating B. So right here B. So and A is not dominating B. Now try to compare the contribution of A with C. So if we say contribution with A and C, so see the salary is also maximum, saving is also maximum. So we can say that A dominates, the contribution of A dominates C, or C is dominated by A. Similarly, you can check C is also dominated by B, and A and B also dominates D. So in the front one you will get, that is non-dominant front F1, you will get AB. Now compare with C and D. So C is dominating over D. So in front 2 you will get C, and last front, that is D, you will get the front 3. So in terms of that you can also draw one diagram. So let x-axis represent salary and y-axis represent savings. So there is the scale 100, 150, 200, and the scale is 65, 85. So as this is the parameter. So now plot A. So A is 200 and 82. Somewhere this will be A. Now B is 195, but it is that 85. So B is here. C is 150, 60. So here is C. D is 140 and 50. So somewhere here is D. So as we are solving the maximizing problem, so as we have discussed earlier, so for maximize problem, this is front 1, this is front 2, this is front 3, like that. So as here both are maximized. This is also maximized, it is also maximized. So with this example, I hope you have understood the non-node sorting concept. Let's try to understand these things by few more examples. So now here we have some uh, variables or string. So that is numbers is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for some value s is some parameter. So we here we want to minimize s and also we minimize t. So here it is minimize problem. Parallel front will lie here. So that will be front 1. This will be front 2. This will be front 3. Like so here we are minimize both. We have discussed it earlier. So here we minimize. Here we minimize. Now at 1 the value of s is something like 691.5. T is 1005.7. At 2 value is 111.8. T is 190. 3 117.4. 234, 4 is 270, like that we have some 12 values. Now try to understand here that the value which is variable in 8, so this is dominating everywhere. See, this is the minimum here, this is 155 also minimum here, so we can say that f1 there is 8. So now calculate leave the 8 terms. Now next is that if you try to find 8 is, then the list is here 2 118, so and 190. Okay, 190. So here f2 you can write this is also equal to 2 2. Now when 2 is over, now leave 2 here, drop the 2 from the list. Now try to understand another thing, list that 3. So here is also minimum 174, 234 is also minimum here. So F3 you can write it the value which is 3. Now you can write, try to understand these two variable 4 and you can understand 11. So here the S is less in 4 but T is less in 11. So 4 and 11 are not dominating each other, but I think 4 and 11 dominating every others. So in front 4 you will get 4 and 11. So this the concept, it will be better if we draw some diagram. So we are again drawing the diagram, try to understand this concept. So these are the value of S and T of 1, 2, 3, 4 up to 12. So now plot it. Plot is something, scale is that from 0 to 100. So first one is this is 0 to 100. So this is 100, this is 200, this is 300, this is 400, this is 500. So for two dimension problem we can do it by the plotting, but there is some algorithm, we'll discuss it. 600, 700, 800, like that. So now one is, here is S is 691, so definitely it will lie here, and this is 1005, so it is 100, 200, 300, 400 up to 1000. So there is A, so we plot A here. Similarly plot 2, 118.190, something 2, similarly 3, like that. So if you draw the diagram from here, you can say that is F1, this is F2, this is F3, 411 is F3, F4, so that is F1, this is F2, this is F3, this is F4, and there is 6, 5, 6, 12 also. So you may write here from the diagram. You can also do diagram your own. So F1 is 8, so that is, you can say, non-dominated front. This is non-dominated front, and similarly F2 is 2, F3 is 3, F4 is 4 and 11, F5 you can write it 5, 6, 12, etc. So you can draw these things. Now we'll try to understand these things by some sorting technique. So let's try to understand the sorting technique. So here the same example we took, that S and T 691, like that. So now non-dominant sorting we are discussing. So after the combined populations, RT basically you know that is PT union QT. PT means the initial population. From there you cross over mutation, you will get child populations like that. So after the combined population RT is obtained, non-dominant sorting operation is applied to find the best non-dominant front. Okay. So here there is some, there is one list, another list is here. So write one here and rest element 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right here. Now compare with 1. So 1 is 691.5, 1000.57. So definitely 2 is less, so 2 dominates 1. So now you replace 1 with 2 and continue the sorting. So 2 is here, we replace the 2 here. Now compare with 2 and 3. So this is dominating, 2 is also dominating, 4, 5, 6, 7. So 2 dominates 3, 4, 5, 7, but 8 dominates 2 because the value of 2 is 118, here is less, 190, here is less, so 8 dominates 2. So again we replace, so 2 is replaced by 8 and sorting is continue. So there is 8, so we drop 1, 2, 8 is there. So compare with 8 with 9, 10, 11, 12. So 8 dominates 9, 10, 11, 12. So hence first non-dominating front, that is F1 is 8. The same thing we draw our diagram also. Now you drop the 8 from the list, drop the 8 from the list. Now compare with the same thing. So again 1 and 2, so 2 is there. Now again compare, so 2 dominates 3, 4, 5, 6, 7, 8 is already we got at front 1. So now 9, 10, 11, 12. So in front 2 will get 2. Now again same thing. Now we drop 2 and 8. So now compare 1 and 3. So 1 and 3, 3 dominates 1, and also compare with 3 with 4, 5, 6, 7, 9, 10, 11, 12. So 3 dominates 4, 5, 6, 7, 9, 10, 11, 12. So the third dominant front is F3, which is 3. Now again 1, so we drop 8, we drop 2, we drop 3, so 1 is there. So compare 1 with 4. So 4 dominates 1, so you have 1 may be replaced by 4, so 4 is there. So now compare with 4 and 5. So see 4 and 5. So 4 and 5, as I said that here the 4 S is minimum and 5 T is minimum. So here not 4 and 5 form a non-dominating set. So there should be 5 there. So now there should be 4. So now 4 dominates 6, 7, 9, 10, 12, but not 11. And 11 dominates 5. So the first dominated front is 4. Then the next dominated front is, that is you will get F1, F2, F3. So that is F4 is 4, 11. So please try to understand what one more time it is. So here 4 and 5 are non-dominating. So we write here 4 and 5. So compare 4. So 4 dominates 6, 7, 9, 10, 12, but not 11, because here 4 is 275 and here is 425, here is 404. So 4, 11 is not dominating, but 11 dominates 5. 11 is dominates 5 here. So 11 dominates 5 because they are both values are less. So you can say that first and the next front non-dominant sorting is that F4 is 4 and 11. You need to remove the 2, you need to remove 8, remove 2, remove 3, remove 4, remove 11. Now compare with 1 and 5. So 1 dominates 5, so 5 is here. And if we form like that, so in the next front you will get 5, 6, 12. So I hope you have understood how to find the non-dominating fronts within the diagram and within the comparisons. So there is some example. So here uh, time and cost for value A, B, C, D, E, F, G, H, I. So there are values. So we need to minimize time and cost. So that should be the, as we minimizing time and we are minimizing cost, the front, this will be F1, non-dominating front, then this should be F2 and so on, it will process. So now try to understand these things. So A is 2, 7.5, B is 3 and 6. So if you compare A with B, see cost is their maximum, here time is also minimum of these two. So you can say these two are non-dominating. So similar way, and also if you draw the diagram, you will get A, B, D, F non-dominating front. C, E, G is also front 2 is not dominated, and H I also not front 3. So there is one easy concept to dominating or not. So the concept is that suppose you are solving one minimize problem. So that is F1 minimize, F2 is also minimize. So there is 2.1 is here. Suppose another point 2 is here, somewhere here too. So if both are minimized, so put a piece of paper like that and move it to downwards like this. So wherever the point you will get, you can say these are, if there is some point, so you can say this, suppose there is A point, so A is dominating 1 like that. So similar way, if you put a paper, both are minimum points, so you can see that nobody is dominating A, nobody is dominating B, D. But if you write C paper here, then if you go downwards, you will find B. So now compare C and B. Uh, so if you put a paper here, so if you put a paper, then you can find that here that B is dominating, because you find B, so B is dominating C. So that is another concept. So when it is maximum, paper will go upwards like that. So you can understood what I'm saying. So this is also an easy way to find the dominance relations. Okay. Now non-dominating sorting genetic algorithm. So that is the NSGA-II. So we have understood the term non-dominating sorting. So now, as you know, this is proposed by Dave et al. In the 2000. So key feature is that is emphasizes non-dominating sorting. We know these things. Now you just diversity preserving mechanism. So that concept we want to we will learn it. So it does background comparison. So it also just illustrates principle. Some of the parents go directly to next generation based on the above mentioned condition, that is the dominating and also the crowd preserving. So non-dominating rank comparison. So given two solution I and J, if the solution I is preferred to solution J, if the rank of I is less. Okay. Fitness assignment. Solution in non-dominating front 1 are ranked 1 and have highest fitness. Solution in the same front have same rank and same fitness. A solution with lower dominating rank is preferred. So key feature is that it converts to Pareto optimal. Diversity is preserving like crowd distance mechanism. So we want to learn the crowd distance mechanism. So it create offspring and combine population RT rank and sort population due to performance on different target indicator. Take best member to create new population, including a good spread in solutions. So step one is that we combine parent PT and offspring QT that we discussed in the last class also. So RT equal to PT union QT. Perform a non-dominating sorting to RT and find different fronts. Set new population, that is PT plus 1 is null set I equal to 1. So then until the number is less than the n, will perform PT1 equal to union Fy and at increase I, the next front. Now include the most widely spread solutions from n minus pt plus 1 of ith front and using the crowd distance value. So we need to learn the crowd distance. So try to understand what is this. Is the basic concept of the NSGA-II. So we want to now find the crowd distance. Sort for all I solution in Pareto font in ascending order of FM. FM means the objective, and compute CDIM. So this is the one formula, crowd distance of the some variable, that is some string. M is the number of objectives. So formula is that FM, it is, we need to sort for that. FM x plus 1 minus FM x I minus 1, and it is the maximum value of FM. So write FM maximum minus FM minimum, and it is one objective. There is M objective. Then crowd distance of point I is summation m equal to 1 to m the crowd distance im. For 2, then it will be definitely crowd distance of point A. Suppose there are two functions, then CDA equal to CDA F1 plus CDA F2, like that. So given two solution I and j, the solution I is preferred to solution j if it is rank is less. I mean front one selected our front two, like that. If these two are equal, then more crowding distance will be selected. So crowd distance more is selected. So that is from the less crowded area. So crowd distance is, if crowd distance is more, then that point is selected. Then it is selected. Then it will be selected. So this is the concept. We need to learn how to find the crowd distance. So there is some example which also I wrote earlier. So here A, B, C, D, F, I give some variables. The two objective, time and cost. We want to minimize both time and cost. So that is 8 to 7.5, like that. So this is table. So we want to find the crowding distance of A, B, D, F. So now A, B, D, F. So here is time and cost. We are not discussing the other variables. Only we are discussing A, B, C, A, B, D, F points, not the other points. So for A, you know that time is 2, cost is 7.5. Then for B, time is 3, cost is 6. For D, time is 4, cost is 5. For F, time is 5, cost is 4.5. Okay, so crowd distance formula, as we have seen earlier, that is CDIM equal to FM xi plus 1 minus FM xi minus 1 by FM maximum value minus FM minimum value, and we need to add after that. Okay, so here first thing is that you need to sort. So for the time, ascending order sorting, so we need to sort is time, sort in ascending order. So first is A, then B, then D, then F. Second, you sort the cost. It is also in the ascending order. So first point is F, then it is D, then it is B, then it is A. So ascending order. So now those who are in the boundary A and F. So here is that, here this formula I is here. So above that you will get x plus I plus 1 here. Here you get x I minus 1. So at the boundary point, crowd distance was it is less crowded area already. So their crowd distance of point A, you can write it infinity. Crowd distance of F, so you can write it infinite, because they are already in boundary region, means the less crowded area. Okay, so now we need to find the crowded distance. We need to find the crowd distance of V and D. V and D. So this is the formula. So whenever we find the crowd distance of B, will take, this is B is I. So this point will be xi minus 1, and this point will be xi plus 1. If we take di, so this is I, so this point will be xi minus 1, this point will be I plus 1. So that is for D here, so this will be xi minus 1, this will be xi plus 1. For B, this is I, so this point will be xi minus 1, this point will be xi plus 1. So here one more thing we may write here, that maximum value of time. So if I write f1 is time, so f1 or f time, the maximum value here you can write c f time minimum value is 2. If cost maximum value, you can write it like this is 7.5 and minimum is 4.5. So you can write f minimum for cost function you can write it 4.5. So that will be there. So now we are going to find the crowd distance for the point B and for the point D. So we are going to find the crowd distance of B. So C D B. So here the formula is that we need to find B. So we okay. So this is B. So we need to find the value of X. So X is here. We need to find the value D first. So D is 4 minus 2 by 6 minus 2. So here you will get it. Here we will get it. CDB equal to, this is for time, 4 minus 2 by 6 minus 2. For cost you will get 7.5 minus 5 by maximum is 7.5, minimum is 4.5. So there we will get 0.50 plus 0.83. So you will get it 1.33. Similarly, crowd distance for D, that will be 5 minus 3 by 6 minus 2 plus 6 minus 4.5 by 7.5 minus 4.5. So that is 0.5 plus 0.5, that is 1. So your crowd distance is more. So that is less crowded area. So you can say that the point B will be selected. Point B will be selected. Okay, so that is the concept of crowd distance mechanism. Now try to understand one more example. So that is, we want to minimize f1x equal to x square. We minimize f2x equal to x minus 4 whole square. X belongs to 0 to 8. So at certain point t, the parent population we assume 2, 4, 6. After crossover and mutation, we got offspring, that is qt. So 1, 3, 5. So rt equal to pt union qt, that is 1, 2, 3, 4, 5, 6. So that is individual a, B, C, D, F. There is 6 values. So A is 1, B is 2, C 3, D 4, E 5, F 6. So F1 is simple x square. So it is 1, 4, 9, 16, 25, 36. Similarly for F2x, if you put 1 you will get 9, 4 you will get, if you put 2 you will get 4, then 3 you will get 1, 4 you will get 0, like that. We are minimizing these two. So now if you plot this, so suppose this point is 0, 5, 10, 20, 30, 6, 1, 4, 9. So for the value A is 1, 9. So A will be here. Similarly B is 2, B is 4, 4. So that will be something here. C is 9, 1 here. D is 16, 0 here. E is 25, 1 and F is 36, 4 to here. So it is here. So again you can also do the comparison. So if you compare, you will see that A, B, C, D, these four are non-dominating font. So F1 is A, B, C, D. You can write to F2, that is E, and F3, that is F. So now we need to select three individuals. So at font 1 itself, we need to do the crowd distance. So now we are doing the crowd distance mechanism. So here for F1, A, B, C, D. So order is 1, 4, 9, 16, and F2 is D, C, B, A. So at boundary point A at D a boundary. So that crowd distance is already infinite, because now here is I. So that is I minus 1, I plus 1. So crowd distance of B, so that is for F1. So B is here. So x plus x I plus 1. So that is 9. Here is B. So 9 minus 1. Maximum is 36. Minimum is 1. So that 36 minus 1. Plus F2. Here is B is here. So again you will get 9 minus 1. 9 minus 0. So that is 8 by 35 plus 8 by 9. So that is 1.11746. So look, crowd distance for the point C. C is here, so 16 minus 4, 36 minus 1. C is here, so 4 minus 0 by 9 minus 0. So that is again you will get 0.78730. So here this is the distance is more, so it is less crowded area. So B will be selected. So in the next populations, we will take A, B, D, that is 1, 2, 4 at parent populations. Again we will do the crossover and mutations, then again we'll get rt plus 1. So we'll continue this process. So that is pt plus 1, this is qt plus 1. So again we'll do the some more iteration to get good result. So that is basically NSGA-II. We'll solve few more examples. Now we need to do the crowd distance for the first problem. So that the problem which there are 12 variables. So we plot the graph. If we have front 1 8, front 2 2, front 3 3, front 4 4 and 11, front 5 is 5 6 12. So thing is that we need to select next parent populations. So pt plus 1, next step we need to select 6 individuals. We need to select 6 individuals. So here is that front 1 1, this is 2, then this is so 3, then 4. We already have 5 from f1 f2 f3. So from f5 we need to select one individual. So that's why we need to do the crowd distance here. So everything is same. So the formula for crowd distance, so if everything is same like this formula x minimum maximum, so here we now try to understand the formula for the crowd distance. So this is maximum minimum, so this is 5 6 12. So here again you will get the crowd distance here for 5 6 12. So try to understand here if you sort it. So I1 for the objective one 6 12 5, and for I2 5 12 6. So these both are infinite. For crowd distance for 5 is infinite, for 6 infinite. So crowd distance 12 we have calculated here. So there is only one vacant place, so we'll choose either 5 or 6. So in the next iterations we have the sixth individual, that is from front 1 8 2 3 4 11. Here either 5 or 6. So this will be act as pt plus 1 for the next iteration. So either this, or you can also have this thing also. So 8 2 3 4 11 and 6. So either this, so you need to do the uh, you need to do the text iteration the same thing. So that is the non-abundant sorting as well as the crowd distance, and you need to apply the NSGA-II algorithm. Okay. So in conclusion, I hope you have understood the details of NSGA-II. So question is that assume any assume any 10 initial populations and we minimize f1. Suppose this is f1 equal to something like x square plus 2x, and f2 is equal to x plus x square by y. Both are minimizing. So try to find the Pareto front. Try to find Pareto front. Try to find Pareto fronts. So this is the today's questions. These are the references of today's class. Thank you.